Hello. This video is for the IXL activity titled Identify Functions. Its three-character code is Victor Lima Lima. At the time of this recording, this activity can be found at A1.Q.4. All right, so what is a function? Well, we've been talking about relations, and now we're going to talk about functions. Functions are relations, but not all relations are functions, kind of like all dogs are animals, but not all animals are dogs. So, definition of a function I have here on the right. Function is a special relationship in which every input has one and only one output. So remember that input is our x values and output is our y values. So in a relation, if a relation has, if every x value or every input of the relation only has one output, then that relation is also a function. So hopefully the questions will explain it whenever I get into that, and it'll be a little bit more clear. So let's look at this mapping diagram. In another activity, we talked about where this is mapping a relation, and we're going to find out is this relation a function, which is pretty much the goal of this activity. So we know that a function is a special relationship in which every input has one and only one output, or every x value has only one output. And we know that our domain, let's put some notes here. So we know that our domain is our inputs, and we know that that is our x values, and that the range is our outputs, and that these are y values. So we're looking for to see if every one of these x values here has only one y value that it's paired up with or that it's matched up with. So as we look at 12, or right away we see that it's 12 is paired with both 19 and 17. So I'm like, oh, hey, nope, not a function. It's a relation, but it's not a function because 12 is paired up with both 19 and negative 17. Now, if we were to, let's see, can I cover that up? Let's see how you do that. If I were to cover up this one right here and get rid of that one there, where 12 is paired up, say 17, then we would have a function, I believe, because 12 to 19, 16 to 14, 10 to 8. Oh, we'd have to get rid of the 6. 6 is paired up with both 10 and 13 as well. So we would have to go ahead and cover up this one as well. And then at that point, it would be a function. But both 12 and 6 have more than one output. That is to say that they're paired up with more than one y value, correct? And let me see the rest of them. I'm looking to see. I'm hoping that 13. Nope, nope. I was hoping that after doing that, that I would have one that was like pointing at two of them. Let's go with the blue line since that's what they're doing. This would be legal. We could have. Let's get rid of. I know what I want to do. Let's do this. Let's pretend. Let's get rid of 10 being paired to that, and let's go ahead and pair 10 to something else, and we'll pair it to say 13. This would be okay. It's all right for two different x's to be paired to one particular y value. And the story I like to tell with this, or the analogy, that over here, these are the shooters, and over here, these are the targets. And one person, one shooter, cannot shoot at two targets at the exact same time. Might be able to shoot one, then quickly shoot the other. But in this case, especially when we have mapping. I like mapping because I kind of like that shooter target thing. So if you see that one shooter is shooting at two targets at the same time, not a function. But yet two shooters like 10 and 6 can both shoot at the same target. That would make sense, right? You and someone else both shoot at the same target at the same time. That's possible. But you yourself or no one else can shoot at two targets at the exact same time. So I kind of like that. The domain is the shooters, the range is the target. So that's to say the X values are the shooters and the Y values are the targets. So let's go ahead and move along with this and look at our next one. So now we have ordered pairs. One thing we know about ordered pairs is the X value comes first. Let's get some notation here on that. So all of our X's come first and our Y's come second. So, well, in order to have two X values, two different, or the same X value, going to two different numbers, we'd have to have the same X value show up in our ordered pairs or a map or a graph or whatever it is that we're looking at, right? Well, I have a 14, 18, 16, and 5. So I know that none of these numbers show up twice, so it would be pretty much impossible in this set of ordered pairs to have the same x value paired up with two different numbers. So I know straight away that this is indeed a function. Let's look at the next slide here. And on this one, it says look at the graph. Is this relation a function? Well, let's see, check out our x's here. Here we got an x value of, and I'm going to assume this is -1. They don't tell us what it is, but this x here is paired up with 1. We got 1 right here, an x value there. We got x value there. There's only one dot, right, on any of these. And then we have this x value here, so it looks like, indeed, we're good to go on this one. We don't have any x values or the vertical lines where we see our x values show up, right? And we don't have any of them where there's two dots on it, so we're good to go. On the next one, let's look here. It looks like there's going to be a problem right here, right? On where x is, well, I guess we'll assume that this is a value of 2, but where x is 2, we've got, looks like both 1, 2, 3 different y values, right? So straight away, we don't have to go any further. All it takes is one violation, right? Just takes just one x value to have more than one output. That is to say, be paired to more than one y value to disqualify it. Now, it is a relation, but it's not a function. On this one here, we have two questions. Both of these are tables. Our x values are in the left column, the y values in the right. So let's go down and look through 19, -8, 18, 5. Well, once again, none of these numbers show up twice. So I already know that it would be impossible to find the same x value paired up with two different y values. So since I don't have anything showing up more than once, this is a function. Let's look at the next one, 13, 17, 2. Oh, we got two 2's here, right? And 2 on this one, put in a 2 and you get an output, inputs and outputs. You input a 2 and you get back a 1, and then you input a 2 and you get back -17. So that means that 2 is paired up with both 1 and -17. So this means that this one input actually has more than one output. So it's not a special relationship in which every input has one and only one output. So the answer is no, it is not a function. On the next one here, we have some ordered pairs. Remember, first number is our x value, second one is our y value. So we're looking to see, can we find an x value that shows up more than once? 10, oh, two 10s right here. The first one and the last one. Well, up here, 10 is paired with 11, but down here, 10 is paired with 5. So therefore, it is not a function. We got a same x value that is being paired up with two different y values. And then here we are with another mapping. We have 14, -14, 19, 5, and 12. And basically, remember, shooters on the left, targets on the right. Can you shoot at one target, two different targets at the same time? No, you cannot. So 14 shooting at both 4 and 8 can't do that. So that makes it to where it is not a function. Now, if in the event, I think as I was getting ready, prepared for this, I was thinking, this is the one I was thinking about. Actually, let me undo that and get a line. There we go. Easier to pull a line than it is to draw. So if I got rid of this one here, I think all of a sudden it becomes a function, because all of these, 14 just to 4, -14 to 19, 19 to 3, 5 to 19, 12 to 19. And you might be, well, look at 19. It's getting like 3 different arrows pointing at it. Is that a function? Well, it's over at the targets, right? So -14, 5, and 12, those shooters are all shooting at the same target. That's okay. What makes it not a function is the fact that up here, 14, shooter 14 is shooting at both targets 4 and target 8 at the same time. Can't do it. It is not a function. So that is my final example for this IXL activity of identify functions. Now go level up your learning.